All right, tomorrow we're going to start looking at finding cosine, sine, and tangent of an acute angle and using those trigonometric ratios. Remember, that's the comparison to find the side lengths in right triangles, and then later we'll use it to solve real world problems. So the first thing we need to do is we need to learn how to use our calculator to find the trigonometric ratios, because the calculator has already been set up to find the ratios between the sines. So all you got to do is be able to use it. Make sure that your calculator is in degree mode, and the way that you do that is you hit shift mode and then choose option number 3, because that is the degree mode. So if you want to do that, you're going to go to your calculator and you're going to press shift mode, hit option 3 to make sure it's in degree. Then you want to press sine on the calculator, which is right above the closed parentheses, 52. Be sure to close your parentheses. And when you hit that, you get 0.7880, and it keeps on going. Now it asks you to round to the nearest hundredth, so that would be 2 decimal places. So here are your 2 decimal places. Check to see if it needs to round up. The 8 is 5 or larger, so my answer would be 0.79. Here's another example of using the calculator to find the cosine ratio. This wants us to find the cosine of 19, and since we've already got it in degree mode, we don't need to do that again. You just locate the cosine button on the calculator, which is right above the SD button. Press 19. Be sure to close your parentheses. Press equals, and that tells you the answer is 0.9455. And then again, it wants you to round it to the nearest hundredth. And remember, hundredth is 2 decimal places, so we know we want these 2 numbers in there. Let's check to see if it needs to round up. It is 5 or larger, so rounded would be 0.95. All right, here's just some information. Since the hypotenuse is always the longest side of a right triangle, the denominator, the bottom part of sine or cosine, will always be larger than the numerator. So that means that the value of sine or cosine is always going to be a positive number less than 1. It's going to be somewhere between 0 and 1. Since tangent of an acute angle is the ratio of the length of the legs, it can have a value greater than 0 or greater than 1. It can be less than 1, but it will always be positive. So now what we want to do is we want to use what we know about trigonometric ratios and the comparison of the sides to find the length of sides without having to draw another triangle. Be careful when you work these problems to identify the side you want to find. The question asks us to find the length of QR. So if we locate QR, we see side QR is right here. 63 is going to be theta because that's our angle measure. So we know that QR is across the triangle from angle P, or 63 degrees, so that would be our opposite side. We know the value of the hypotenuse because it's opposite the right angle. So we want to use a ratio that compares the opposite and the hypotenuse. And that if we look at our formula sheet, we see on our formula sheet the ratio that compares opposite and hypotenuse is sine. So we're going to set up our function. So we're going to say sine. In this case, theta is 63, so we're going to substitute in 63 for theta. Equals the opposite side, which we don't know, so that's x, over the hypotenuse, which we do know, is 12.9. Now, the easiest way to solve that is go back and remember that we use proportions to solve those. So let's make this a proportion. And when we cross multiply, we're going to multiply sine 63 times 12.9. And that's going to equal, when we cross multiply the other way, 1 times x is x. So since x is already isolated, all we've got to do is put sine 63 times 12.9 in our calculator to get our answer. So when we do that, we're going to go locate the sine button and press sine 63. Be sure to close your parentheses, times 12.9, and the calculator tells us it's 11.49. Now you always want to check and make sure your answer makes sense. So if the opposite side is 11.49, that is less than the hypotenuse, and we do want it to be less than the hypotenuse, and it is somewhere close to it. So our answer does make sense here, like the standards of mathematical practice asks us to do. All right, in this one, it wants us to find FD. So let's locate FD in the picture. We know that theta is going to be 39 because that's our acute angle measure. FD is my hypotenuse. And FE has a measurement of 20, so that would be my adjacent side because it is beside. All right? So we want to find the ratio in our formula sheet that compares the adjacent and the hypotenuse, and that would be cosine. So in order to work that, we're going to use the cosine function to set it up. So we're going to substitute cosine of theta. Let's substitute 39 in for theta since that's the angle measure. Equals the adjacent side, which is 20, over the hypotenuse, which we don't know. So that would be x. And then we want to set up our proportion so we can find x. So if we do that, and I cross multiply this way, that gives me cosine of 39 degrees times x equals, and cross multiply the other direction, 20 times 1 is 20. Now on this time, x is not isolated, so we need to solve it. So the opposite of multiplication is division. So let's divide both sides by cosine 39. And the cosine 39's cancel on the left. So we're going to get our calculator, and we're going to make a fraction bar and hit 20 in our numerator and press cosine 39 in our denominator. Be sure to close your parentheses. And it's going to tell us that x equals 25.74. And if we put our answer up here on our hypotenuse to make sure it makes sense, should our hypotenuse be 29.74? It is larger than 20. It is somewhere in the same range, so 29.74 does make sense here, like our standards of mathematical practice asked us to do. Here's another example. This time they want us to find side BC. So locate BC on our picture. Identify theta. Theta is our 15-degree angle measure. BC would be the adjacent side because it is beside angle B. And then if we look at 10.2, it's not the hypotenuse, so it needs to be the opposite side. So we want to use our formula sheet to determine which ratio compares opposite and adjacent. If we go up here to our formula sheet, that tells us tangent compares opposite and adjacent. So we're going to use the tangent function for the ratio. So tangent, we're going to substitute 15 in for theta because that's our angle measure. We know the opposite side is 10.2, and we don't know the adjacent side, so it will be x. And again, the easiest way to solve these is use proportions like we've been doing all year. So if I set up my proportions, I'm going to cross multiply. That gives me tangent of 15 degrees times x equals 1 times 10.2, which would be 10.2. Now we want to solve it. So in order to solve, we've got to isolate the x, so we need to eliminate the tangent 15. We're going to do that by doing the opposite of multiplication, so that would be division. So we would divide both sides by tangent 15. The tangent 15s are eliminated on the left side, so that leaves me x equals, and I need to get my calculator, use the fraction button. 10.2 is my numerator, and tangent 15 is my denominator. Be sure to close the parentheses. So that would tell me that x is 38.07. If I check to make sure it makes sense, 38.07, I look at the adjacent side. 38.07 should be longer than 10.2 because the picture shows that relationship, and it is somewhat close to that, so that's a pretty good answer. All right, let's look at the next example. They want us to find side ST. Well, here's locate side ST on our picture. Theta will be 42 because it's the acute angle. ST is a legs, and it is beside, so it would be my adjacent side. Here's my right angle. So my right angle always points to my hypotenuse. That would be my hypotenuse. So I want a function that will compare the adjacent side and the hypotenuse. I look at my formula sheet. I see cosine compares the adjacent side and the hypotenuse. So I'm going to use cosine. Theta in this case is the 42-degree angle. The adjacent side is x. The hypotenuse is 9.5. The easiest way to solve it will be to use proportion. So let's make this a proportion. If we cross multiply, that gives me cosine of 42 degrees times 9.5 equals, find the cross product of there, 1 times x is x. And since x is already isolated, we can just put this in our calculator the way it is. So we would press cosine 42, close my parentheses, times 90.5, and that would give me 7.06. So we know that x equals 7.06. Now we need to make sure that we use our standards of mathematical practice, and let's make sure our answer makes sense. So that would give me 7.06 as the adjacent side. I know the adjacent side should be less than the hypotenuse, and it is. And 7.06 and 9.5 are pretty close. So that gives us how to do these. We'll work on these some more in class tomorrow. So if you have any questions, be ready to ask them at the beginning of the class.